In the previous part of the video, we saw the benefits of normalization. We also saw how normalization helps you to avoid redundant data and erroneous data to enter into your systems. Now I'm sure that somewhere in your mind, the three normal forms must have become golden rules for database designing. But then hang on. There is the other side of the story as well we need to understand before we go and apply these normalization as golden rules for database designing. In order to understand the other part of the story, let us first understand the larger classifications of IT system from the data perspective. From the data perspective, we can classify IT systems into two big classifications. One is OLTP and the other one is OLAP. So OLTP stands for Online Transaction Processing System, while OLAP stands for Online Analytical Processing System. Now OLTP systems are those systems which deal with regular transactions. In other words, your normal insert, update, delete, those kind of queries are more suited, for OLTP systems. And what it also means is that all these operations, that is insert, update and delete, they either bring in data into the system, into your application, or they remove data from your application, right? So what it means is that when the data is coming inside your application, you would like to avoid redundant data, you would like to avoid any kind of erroneous data, or you would like to avoid data which does not have integrity, okay, which we discussed when we were discussing the normalization rules. So in other words, for OLTP system, definitely normalization, that is applying first normal form, second normal form, third normal form, is the right way to go ahead. Why? Because we don't want to get data into the system which is erroneous, which is duplicate, which is redundant and etc. But now let's consider some different operations which are not normal daily transaction operations. For example, a manager wants to take large number of historical data, backdated historical data, and he wants to go and analyze that data. He wants to go and do some forecasting on the data. He wants to do some kind of sales management using that data, right? Now these kind of operations, here the data is not coming into the system, but there is a heavy operation which is done, which is from the perspective of selecting the data, from the perspective of massaging the data, from the perspective of creating complicated reports on it. So these kind of systems are called as OLAP system, that is Online Analytical Processing Systems. So if you try to visualize the overall motive of OLTP and OLAP systems, the main goal of OLTP system is that you would like to have faster inserts, rapid updates, rapid deletes. You would like to improve the data quality by reducing redundancy, etc. While in OLAP systems, you would like to do faster analysis. You would like to search faster. So in other words, the main goal of OLTP systems is more of data manipulation, while the main goal of OLAP system is faster search and faster analysis. Now let me make a statement here. Normalization is not suited for OLAP systems. Why? So what do we do in normalization? As we discussed in the previous video, normalization is all about breaking data into granular pieces, ensuring that we don't have redundant data. So what happens is we end up with a lot of tables. Now when we say that in OLAP systems our main motive is to do faster search, now because the search has to go and pull data from multiple tables, the search starts becoming slower. So in OLAP systems, rather than doing normalization, we do the vice versa of it, that is we denormalize it. So let me just demonstrate why normalized design is not suited for OLAP systems. So you can see over here I have a very normalized design here. So you can see that this is a perfectly normalized database design where I have a customers table which has the contact name of the customer. There is one more table here called as an orders table, which tells me that how much orders these customers have taken. Okay, and second, each one of these orders, I have a detailing, more finer detailing to it, saying that what kind of product he has bought, how much quantity it is, and what is the per price of each one of those product. Okay. So now let's say that you want to go and derive a very simple report here which says that, okay, give me the contact name of the customer, give me the unit price, give me the quantity and the total sales. So what I'll do is, we already have all the fields, but we don't have the total sales. So for total sales, we need to multiply the unit price with the quantity. So I'll just say here comma, and I'll multiply this unit price with the quantity. Okay, right. So this will give us the total sales to us. Okay. So if I do execute again, you can now see that we can see there is a contact name, there's a unit price, quantity, and the sales is the multiplication of both of them. Now let me just take this SQL here, Control C, and let me open up a new query window here, and let me just go and see the statistics of this SQL. So what I'm going to do is I'm going to go and on my statistics here. So in order to go and on your statistics, you have to say set statistics IO on, and let me say execute. Now once I do execute, right, let me, you can see that it has gone ahead, it has executed the SQL, that is fine. But let's go to the messages. Now this is very interesting here. Now in the messages you can see that in order to get this data, right, he is making an inner join with the orders table, he is making an inner join with the customers table, he is using the orders details tables, and you can see that there are lots of logical reads as well happening over here, right? Now if you think about OLAP systems, where the search has to be faster, reading from so many tables is definitely not efficient. In other words, it will definitely slow down your select query. So how about, rather than keeping this data into all of these tables, how about taking all this data and combining it to one table, some denormalized table. So what will happen is, rather than going and making selects into all of these tables, we can just go and make a select, into that one big denormalized table, and we can improve our efficiency. So what I've done here is, you can see that I have created one more table here, which is called as the customer denormalized table. So if you go to the design here, I have created this one big table. What it does is, it just takes the customer name and the total sales. So what will now happen is that if I go and just select this table now, okay, and if you see this table, already all the import has been done into this table, all the backend activity of calculating, multiplying, everything has been done, and the whole aggregation is now stored into this table. So if I see the efficiency of this select now, the first thing is we have got rid of all the three tables and we have only one table now. So definitely our read is all efficient. So if you go and on your statistics over here, set statistics IO on, if you execute this, you can see now he is only fetching from one table. So if I take this one, let me just Control A, Control C, notepad. So this thing is coming from denormalized, right? And this thing is coming from normalized. So you can now see from this both statistics, right? The first thing is the number of tables in normalize is higher, so definitely the select is slower, right? And if you see the denormalize, the select will be faster. Why? Because you are only fetching from one table, right? So number of tables have decreased. Second, if you also look at the scan count, I'm going to see the scan count here is 91 plus 1 plus 1, whatever it is, but here the scan count is only 1. Look at the logical reads. At one end the logical read is 184 and adding to it other 11 and 5, while here the logical reads is only 9. So in other words, denormalization is all about combining the data into one big table, rather than going and fetching data from multiple tables. So summarizing, what exactly is denormalization? Denormalization is absolute opposite of normalization. In other words, in denormalization, we can have redundant data, we can have duplicate data, we can have aggregate data. We will actually violate the three normal forms. Why? Because our main intention there is to make our search faster. When do we use denormalization? Denormalization is very much useful, for OLAP systems, where faster query, where faster analyzing is more important rather than insert, update and deletes. Where do we use normalization? For OLTP systems, where our main goal is to do insert, update and delete, and we want quality data to enter into our system. Now said and done, it does not mean that when you want faster searches you start applying denormalization haywire. In other words, it does not mean, okay, now here there are 4 tables, let's make it one table. Let's make this 10 tables one table. No, that is not the way. Again, in denormalization, we have two great techniques here which we can apply and make our OLAP systems much better. One is the snowflake design and the other one is the star design. So what we'll do is, in the next part of the video, we'll try to understand both of these denormalization techniques, which can help us to make our OLAP system much better. So I hope that you enjoyed this video. In the next video, we will understand both of these denormalization techniques. Thank you so much. Now here's a small favor you can do for us, or I'll say it's a small request from us. Okay. If you think that whatever we are doing here on this channel is cool, it is nice, it will help out people, what you can do is you can go ahead and share this video, either on your Facebook account, on your Twitter account, on your Orkut, on Blogger, whichever channel you are associated with. Please do go ahead and talk about this video. By doing this small favor, you are helping us to know that what activity we are doing, is it worth for the community or not. So go ahead, if you like this video, share it on your Facebook account, Twitter, Blogger, MySpace, Orkut, Google Plus, whatever it is, and let the world know that here's a resource of videos, which .NET developers can see and they can learn from it.